YouTube channel Learn with Lakshminarayana. In this video, we are going to learn about integrated circuit, commonly known as a chip. So, in this video, we will learn about what is an IC, what does a chip works, why chips are so important in today's world, what's inside a chip, types of chips, advantages of a chip, disadvantages of ICs. So let's get started. What is an integrated circuit? It is a small piece of semiconductor material, usually made up of silicon, that contains millions of transistors and interconnection to perform an operation. Before integrated circuits were invented, electronic systems were built using thousands of separate components and connected by wires. Because early electronic devices were big in size and more expensive, consumed more power, were less reliable. However, these modern ICs solved these problems. They combined many components into one compact chips. The nothing but the a small chip can perform more operations, and it is small in size. It is less expensive when compared to the early electronic devices, and it consumes less power and also were less more reliable than our early electronic devices. Although a very small chip, and it can perform billions of operations every second, making modern technology fast and efficient. So when we see in this video, this is the first IC was made by Jack Kilburn, made up of germanium with golden contact wires, and this is the modern IC. It has millions of transistors to perform an operation. We are going to discuss about this modern IC in this video. So we are done in this slide. We are going to the next slide. In this slide, what does a chip works? Chips are the brain of every modern electronic devices. They process information, store in data, and perform the data, enable communication, and control modern technology. In simple words, chips or acts like a brain of every modern electronic devices to become the smart and automated. And chips can process information at incredible high speed, and after stores and retrieve data efficiently, communication through the internet and wireless networks, and also control electronic systems in automobiles, industrial machines, and smart home appliances. And it is power advanced technologies such as artificial intelligence, robotics, IoT, cloud computing, and data centers. So we can see this in next slide also. See here, these all are the applications of the chips. Here we can see chips are used in smartphones, where routers, satellites, and laptops, desktops, server, and data centers. The use of this chip became the important in this world. See, today we are living in the digital world era, where almost everything is become smart and connected and automated. It was done by the this chip, and every modern electronic devices depends on a chip. See, this is all are the modern technologies, right? And electronic device all are made by using this chip to perform an operations, and to control by the these and after they are found. Chips are foundation of today's digital world, enabling devices to make process information. Here we can process the information, and after that make decisions, and communicating. Here we can use the communication and perform billions of operation in every second. And these are all the applications of our chips also, and we have done this slide. See how many in- devices are based on or works by using the chip. Here we can see smartphones, laptop, communication, computing, consumer electronics, health kits, space and defenses, transformation, transportation, smart life and IoTs, in industry and automations, other applications, and also space and defenses also. This makes the chips is more important in today's world, and we are done in this slide. After that, what what's inside a chip? See, these all are the layers of our chip, and this is first one is this is the package of a chip. It prevents the physical damage, moisture, and dust to the this chip. After that, these are the wire bands. It made up of golden. This makes electric connection between the die and package. It provides the electrical connection between this die to the these bands. And after that, bond pads. These all are the bond pads. It provide the connection external environment connection to this chip. After that, position layer. It it protects the die surface from moisture and contaminations. Here, this is the position layer. Here we can see. After that, these are the layers of our chip. First one is silicon die. It is the heart of the chip made from silicon. It contains millions of transistors and circuits. And after that, metal interconnections based on the technology or based on different chips. The metal layers can be also varies, and each metal layers can serve different operation. For example, it can be segregated in three types. One is top metal layers, middle metal layers, and lowest metal layers. Basically, top metal layers are used to give power to our chip, and after that, middle layers are used as a stripes or bumps, and after that, lower metal layers are used to give, I mean, connection to the rails and our standard cells. It directly connected to our standard cells, and after that, interlayer dielectric. Its insulating layer between metal layer prevent electrical shorts. See these many layers of our chip. It prevents the connection between each metal layer. When each metal layers are connected, at the time we will get short. To prevent those shorts, we can use the interlayer dielectric. After that, wires, contact wires. Wires are vertical connections that link metal layers with each other and with transistors. See, we have different levels of metal layers, right? Each metal layer should be connected to other. It's the requirement of our depends on the circuit or depends on the circuit. To connect those metal layers, we use contact wires for the connectivity. After the transistor, we know about the transistor. Transistor acts as a switches that control the flow of electricity in our chip, and it performs the operation. After that, before going to the gate oxide, we should know transistors has three terminals. One is gate oxide, and after that source and drain. This gate can control the flow of current in between source and drain. Here, it made up of a very thin insulating layers such as SiO2 under the gate that control the transistor, means that control the power of, I mean, that control the electric flow in between source and drain. See, these source and drain are heavily doped region that acts as the source and drain of the transistor, and after the silicon substrate. This silicon substrate is the base silicon material on which all components are built. On the silicon wafer only these all the layers are built. After that, we already see the package substrate, and these all are the inputs and outputs of our chip, and this is the schematic. These are the layers. These many of metal layers we are used. These are the here we can see the contact wires, how each metal layer connected to this. And after that, types of chips. Basically, chips can be classified into two types. One is analog IC and digital IC. Analog ICs signal are continuous, and when coming to the digital ICs are binary signals, they are zeros and one. The working principle of analog ICs are process continuously changing electrical signals, and the working principle of digital ICs are process discrete binary data using logic gates, and inputs of analog ICs are varying voltage of current, and the inputs of digital ICs are high and low, are nothing but 0 and 1. It can provide the continuous voltage and current as the output, and digital ICs are provides the output as zeros and ones. Analog ICs are more sensitive than the digital ICs because means analog IC can easily affect with noise, and when coming to the digital ICs are more more noise resistance. It won't affect by the noise mostly. After that, analog ICs are more power consumption based. It depends on the circuit design, and digital ICs are varies with the technology and workload. Based on the workload and technology, digital IC can consume the power. And examples of analog ICs are op amp is nothing but the operational amplifier, voltage regulators, comparators, audio amplifiers, and the applications of digital ICs are CPU, GPU. CPU stands for Central Processing Unit, GPU, microcontroller, memory, and logic gates. So these are the types of chips. Next we can see the advantages of chip. Integrated circuits offers benefits many benefits. See, some major advantages are it is compact in size, means it is small in size. It can do fast operations, lower power consumptions, and it has high reliability and low manufacturing cost, lightweight design. And after that, these are the disadvantages of ICs. Although ICs are very useful, they also have some limitations. These are all are the limitations. Difficult to repair. We can't repair the ICs once it damaged. So after that, limited power handling capability and sensitive to static electricity. So this is all about this video. Thank you for watching.